This video is on exponential growth. An example we're going to use is a population model formula. So this is an example from a textbook in pre-calculus on page 237. The example says the world's population from 1995 to 2003 can be modeled by that equation P equals 5340 e to the 0.012922t, where P represents the population in millions. I'm just going to underline that here. Common mistake sometimes that it's made. And that T equals 5 represents 1995. Question A, what was the population in 1990? So 5 years prior. So the hint, in 1990, our time has to equal 0. The reason why, if we say T equals 5, and that's 1995, so if we go backwards 5 years, we're at time equals 0. So we're going to go ahead and substitute 0 in for T and solve this equation. So we say P equals 5340 e raised to that decimal value there, and then plug in a 0. Multiply that exponent values together, and you get 0. Now if you remember, anything raised to the 0 power in an exponent is 1. Now multiply those two numbers together, and we get 5,340. And that's what the equation gives us. But be very careful. Let's go back up to the question here. If you noticed here in the green, it says the formula is in millions. So we have to manipulate this number a little bit. We have to convert this to millions. So we're going to add 3 decimal places on. Now it is correct. So the population in 1990 is 5,340,000 people. Part B, when will the population reach 6.8 billion? So that's going to be our end amount. A equals 6.8 billion. Now that formula was in millions, so we have to change this to a millions value. So we're going to move the decimal 3 places to the right. 6800 equals now our A. And we're going to substitute that into our formula. And where that goes, it's your end amount. And we're going to solve this for T. T is our unknown. All right, so 6,800 is going in for P, but that's really 6,800 here. Equals 5340 e raised to your exponent, and we're going to solve this equation for T. So the first step is to divide both sides by 5,340. So you're able to isolate the exponent of E. So right side, 5,340 cancels out. On the left, let's simplify that fraction. And this is approximate, 1.27341 equals E. All right, now we want to continue solving for T. So we're going to take the natural log of both sides. When we take the natural log of both sides, the natural log, which is base E, and an exponential of base E are inverses of each other, so they're going to cancel each other out. These two pieces are inverses. So they're going to cancel out, and we're left with 0.012922t. Left side just still stays as it is. Last step, just to divide both sides by that decimal value so that the t is by itself. Cancel on the right. T is left. Enter the fraction into your calculator, and you get approximately 18.7. What that represents is years. Now we need to answer the question. If you remember, t equals 5 is 1995. If t equals 0, then it's 1990. Our t is going to be 18.7 years. So I'm just going to drop the 0.7. That's like 3/4 of a year. And we're going to take 1990 and add 18 years to it. And the year that this is true is 2008. In 2008, you will have a population of 6.8 billion. So in 2008, the population will be 6.8 billion.